In this video, I'm going to show you 3 more examples of how you can graph 2 equations and solve a system by graphing to find the intersection point. And so what I'm going to do is show you 3 actually unique cases. And so the first one that I did, the first video, if you watched it, we had some lines where they crossed, and what we're looking for is the point of intersection. And I talked about how you just want to graph each equation separately, look for the point where your 2 lines cross, and then check your work. And so I'm going to do the same thing here, but you're going to see that we're going to get some unique cases in this video, so stay tuned here. For the first example, we have the equation 2x plus y equal to 4, and we have 6x plus 3y equal to 12. So what I'm going to do for each of these, you can graph these in what is called standard form by solving for your intercepts, but I'm going to solve for y just so I can get a ton of points for my line instead of just 2 points, my x and y intercept. So I'm going to solve for y here, and I'll show you that first. I'm going to subtract my 2x to the right side of my equal sign here. And the equation I'm going to graph is going to be y equals that negative 2x now, because I moved it over, it's going to change signs, plus the 4 that was already there. Now in this equation, I'm going to start on the 4 on the y-axis, so up here, and I'm going to follow my slope then to get my points for my line. I'm going to go down 2 and right 1. You should always go to the right. So if I haven't said that before in a previous video, your slope here is always up or down based on your sign. This is a negative, which tells me I need to go down, and you should always go, whatever the bottom number of your fraction is, to the right. All right, so here we go. Down 2, right 1, down 2, right 1, down 2, right 1, down 2, right 1. You know, get enough points until you feel like, you know, you've got enough where you can easily connect those 2 points on your grid. I like to fill the whole space on my first line, because then I know all those nice whole points in the grid space that I have provided here. And then when the other line I draw it, I can know real clearly, because I've drawn all these dots, where those 2 lines are going to connect. So that's just kind of a helpful tip that worked for me. Maybe it will work for you as well. Now to solve for y in the second equation here, again I need to move my 6x term back over to the right side, because I want it to look like y equals mx plus b. So that's the format I'm going here. And now I'm going to have 3y equals that negative 6x. That's why I want that term in the front here, plus the 12 in the back, because I want it to look like that format for graphing. And then divide by my coefficient on that y, which was the number 3. And so I will graph y equals negative 2x plus 4. So now what I'm going to do, oh, hey, do you see something? I see something here. These are the exact same line, aren't they? Oh, they tried to get tricky and disguise it as 2 different lines. If I graph this line, it is going to be exactly the same line that I have already graphed. And all the points are going to be in common with that line. Okay, so I'm going to just kind of highlight this for emphasis. All right, now, for these 2 lines, if you notice that they are exactly the same, what we're going to do is write down this for our conclusion. I'm going to write down same line. Same line. And what this means is that they will have infinitely many solutions. So the equations are the same. And I'm going to say, so they will touch at all points, all the same points, when graphed. You might see a symbol for this as well. You might see, instead of infinitely many solutions, you might see this symbol here. So in case you see that, that's what that symbol means. It means infinity, infinite number of solutions that those lines will share. And that is my answer. They have infinite many points that they connect at, so I'm going to box that like I did in the previous video with my bright purple pen. Okay, here is our second unique system here. Again, I'm going to solve for y for graphing. And so take a look here. For this first equation, what I'm going to do is subtract 2x to the right side. And I'm going to see here that I have negative y is equal to negative 2x plus the 4 that was here on the right side. Now, I don't want to graph negative y. I want to graph positive y. So divide everything by negative 1. Essentially, what we're going to do is change every sign of our equation And you'll see here, oh, my pencil's just breaking on me. Hold on one second. All right, here we go. So my equation will be y equals now positive 2x and negative 4. So similar to what we had, just opposite signs here. So I'm going to graph this function first. Minus 4 here. And now my slope is positive 2 over 1. So I'm going to go up 2, right 1, up 2, right 1. Up 2, right 1, up 2, right 1. And again, I like to graph all the points in this grid that I have provided for the first line because, you know, then I graph the second line and I can very clearly see which points I put down for where the intersection might be for the second line. All right, so here's going to be my second line. I'm going to subtract my 2x to the right side, and I have then negative y equals negative 2x plus 1 that was already here. Now again, I need to divide everything by negative 1, and I have y will equal positive 2x then minus 1. And I'm going to graph this line here similar to how I graphed the first one. I'm going to start at negative 1 on the y-axis, which would be this point right there. And now again, I'm going to follow my slope. We're going to go up 2, right 1, up 2, right 1, up 2, right 1, up 2, right 1. And maybe you've noticed what's going to happen here. Maybe you haven't yet. But I noticed that my slopes are identical here. And if you have slopes that are identical, then that means your lines are going to have a unique quality. Two lines that have the same slope but different starting points are called parallel lines. And the property that parallel lines have is that they will never touch because they're going to go in the same direction always, but they're always going to be just a couple units apart. Look here, they're 3 units apart here. If you notice, we counted from negative 1, negative 2, negative 3, negative 4. Those are 3 units apart. So this is my conclusion. There is no solution here. And I'll just explain again why I said that. These equations are parallel. So these lines will never touch. All right, I have one more for you. And I got 2 lines here. What I'm going to do is, again, solve for y and graph my 2 lines on the plane here provided. So here we go. Subtract that x over here to the right side, and we're going to graph y equals negative x plus 6. And now this line I'm going to graph, I'm going to start at positive 6 on my y-axis, and I'm going to follow a slope that's negative 1. So we're going to go down 1, right 1, down 1, right 1, and we're going to keep putting points. And we're going to connect all those points with our line. I'm going to use a ruler for my line because I like mine to be nice and straight. So here we go. Put my ruler down, connect all those points that we just drew with our line. And then here's the second one. Oh, got to solve for y first. Let's do that. Subtract our x to the right side. And I have negative y equals that x that we subtracted plus 4. Again, I want my x term in front because I want it to look like that y equals mx plus b. And so now I'm going to divide then by negative 1 because I don't want to graph negative y. I want to graph positive y. Y equals, let's see here, negative divided by negative is going to make this a positive x. And 4 divided by negative 1 is negative 4. So I'm going to start on negative 4 on the y-axis, which would be this point down here. And now my slope is positive 1. So we're going to go up 1, right 1, up 1, right 1. And I'm going to see where that point is. Here it is, where we connect right there. I have found that solution point. I'm going to write that here. Solution. And now I'm going to connect these orange dots with my orange line. And let's label that point. That solution point where these 2 lines cross looks like it is at the point. It's in between 4 and 6, which would mean that would be a 5, and it goes up 1, so 5, 1. This is our solution to our picture, and this is where the the two equations touch at one point when graphed, and this is the intersection. Intersection is 5, 1. Awesome. Great job hanging in there listening to my video, and stay tuned for more.